Good morning everyone. Today we will be discussing about the binary concept in the digital signal, whichever signal it is there. Already you have learned how the signal is being passed from one end to another end. It is mainly the time which is involved while it is said to be transmitting the information from one end to another end. So most important questions when a signal is being transmitted, how much speed does it take, how does it increase the speed, and how much signal is being sent from one end to another end, or whether it is reliable on whichever communication mediums, whether it will reach the data in a certain way in certain time, and whether it is said to be reliable that the message it will be reached to the other end or not. That information it is said to be the most important one. Mainly when it is conveying, you all know the information it will be transmitted in zeros and ones. Okay, when the signal constantly becomes zero, means no data is being passed, means what, some error is there or something problem is there in the network, that it will be conveyed. When it is said to be 1, everywhere 1111, then automatically the signal moves up, it will be going to the upper side. That is said to be a digital binary signal. Okay, it will be in the ones and zeros format which will be there, which will be conveyed on the network. Okay, so the signals, the per second how many signals are being generated, that it will be noted in the systems mainly. Okay, so that is the format of a digital binary signal. And the digital binary signal, as I said, the questions mainly raising is how to increase the speed, how much it is said to be reliable, whether it is said to be reliable for a longer period of time or whether it is said to be lesser period of time, that is said to be there. And the limit of the speed is said to be the most important one when it is said to be transmitting the information. Okay, next one what we will be learning is the pulse transmission rate. It's nothing but how many pulses are being generated in particular 1 second. In 1 second, okay, if I say there are multiple signals are being generated, then it is said to be the rate at which the information is being transmitted. So I want to increase the speed for a longer period of time, then it is said to be having a most reliable and a faster kind of network. Okay, so pulse transmission rate is nothing but, remember, it depends on your t factor, your time factor, when it is said to be transmitting the information from one end to another. Mainly how it is being calculated is, okay, one pulse it carries like this. You can check here the pulse, a single pulse, it will be transmitted. When it is said to be transmitted, it will be calculated in the way 2 WC. 2 WC is nothing but, okay, when it is transmitting in 1 second, it will be transmitting how many 2 pulses per second. So this is your pulse, 1 pulse, 2 pulse, 1 pulse, second pulse. It is said to be returning pulse. So one pulse is generated from top to the bottom. So it will be in the format of 2 cross WC pulses per second, where WC is the bandwidth. This is said to be your bandwidth of your channel. In a channel, the bandwidth, in one bandwidth, how many signals are being generated, okay, that it is being calculated in the network. So pulse rate is nothing but 2 WC pulses per second are said to be generated in 1 minute, 1 second, sorry. Okay, so next we will be moving on to a concept where you will be learning about the bandwidth of a channel. Bandwidth of a channel is nothing but, in the bandwidth, how the bandwidth is being passed. When the bandwidth is being calculated, how it will be your t and x axis. Your x axis is your down axis and y axis your this one. So x is nothing but a cos 2 pi ft. That is the most important one. A cos 2 pi ft. 2 pi is nothing but, in this, okay, degree, when it is said to be 180, how many pulses are said to be generated in this signal? Okay, in this, okay, 10 pulses are generated. So in that particular bandwidth, how many pulses are generated? So 2 pi is nothing but your, at 180 degree, what is the frequency and what is the time it will be generated, that it will be calculated. And mainly the attenuation is also being calculated. When the information is being passed, it will be checked out for the attenuation, nothing but your disturbances in the channel. So how many times the signal has become low, that it has to be calculated. So that part becomes important when the information is being transmitted. So your attenuation is the important one when you are said to be calculating the bandwidth. So bandwidth is nothing but your amplitude cos, amplitude cos, A is for amplitude, cos your 2 pi ft, frequency and time plus your degree at which your information is being transmitted. This is your 180 degree and it will be turn over to a 360 degree later. Okay, when it is said to be a whole pulse, then it will become 360. So here it is 180 in the beginning, so it is that being calculated, and here you are said to be calculating when the signal is being transmitted. Actually, when the information is being transmitted from the X channel, it will be in this format. When it is reaching the other format, it becomes like this. So it will be your Y factor. So Y factor, when this signal passes readily, then it will become A of f is equal to 1. When the signal is not passed, the signal is said to be blocked, then it is said to be a single format which is said to be x of t. Y of t, when it is, when your pulse raises, when it is like no signals are being crossed, means this becomes 0, only it will be considering the a cos 2 pi ft. Okay, so that it is said to be important when it is being calculated. So here also WC is nothing but the range at which your pulse passes. And another one concept is there called as multi-level pulse transmission. Multi-level is nothing but when I am transmitting smoothly. Okay, when I am said to be transmitting the information smoothly, the pulses it will be in this format. Okay, when it is in this format, it will be minus a or plus a. Okay, it will be two WC pulses which will be crossed from one end to another end. But when the pulse rate increases, okay, when my speed increases, automatically your pulse rate starts to increase. Your pulses may generate in this way. Multiple pulses are there. Your frequency also changes, your amplitude also changes. The amplitude, it will be in the format minus a by 3 plus a by 3 and plus a, like that range it will come. So when it is increasing that particular range here, even your amplitudes it will be increasing at a multiple level. So your amplitudes it has increased at a higher level multiple times. So it becomes m bits per pulse. There are m bits which are being generated per pulse, and it is having a bandwidth which is of 2 WC pulses per second. At a second, 1 second, 2 pulses per second it will generate, but it will be generating same way the multiple pulses at a time. So when it is generating multiple pulses at a time, it becomes 2m. 2 means at a time 1 second 2 pulses, and m number of bits it will be traveling at a time. Okay, and WC is the width at which it is said to be traveling. Okay, this is the concept which you have learned about the digital signals, how it is being formatted, how it is transmitted in 1 second, how many pulses are generated, and what is the formula for the multi-level pulses which are said to be generated. So remember, when the signals are being generated, even noise is also there when it will be there in the signal. But though noise is there, it will be generating multiple signals at a time, and it will be having multiple levels at a time, multiple pulses at a time. So that is the thing which you have learned today. Okay. In the next session, we will be learning about the other concept which we will be dealing in the next session.